Welcome back. We are discussing about the Charpit's method. So let us do some more problems of this topic. Okay, consider the question. Solve 2z x minus p x square minus 2 q xy plus pq equal to plus pq is equal to 0. So in this case the given equation is directly of the form f is equal to 0. So let us take this as equation as f is equal to 0, so that f is 2zx minus px square minus 2qxy plus pq is equal to 0. So let us choose this as equation f is equal to, just choose this as equation f is equal to 0. Okay, now we have to write down Charpit's auxiliary equations. Now this is the first step. You have to transfer all the terms in the left hand side to the right hand side, so that our given equation becomes the form f is equal to 0. Now Charpit's auxiliary equations are given by dp divided by fx plus pfz, fx plus pfz equal to dq by dq divided by fy plus q fz is equal to f dz divided by minus p fp minus q fq is equal to dx divided by dx by minus fp dx by minus fp is equal to dy divided by minus fq. Okay, now next step is you have to find all the partial derivatives which are required in our Charpit's auxiliary equations. So from these expressions, equation 1, we can find the partial derivatives, so that you get fx is equal to fx. We are differentiating partially with respect to x, so the remaining variables are constant. So fx is equal to 2z, derivative of x is 1, minus p into 2x. So 2px minus 2qy. This is fx. Now you can find fy. Fy is equal to with respect to y minus 2qx minus 2qx. Remaining terms are constants with respect to y. Then f z is equal to f is z. What is f is z? Only 2x. Then fp. fp is equal to now what is ft with respect to p? So derivative of 2zx is 0, then minus px square is there, so minus x square into derivative of p is 1, then plus q, then fq is equal to what is fq? fq is minus 2xy plus p. So these are the partial derivatives required in our given differential equation. Now we have to substitute these values in our Charpit's auxiliary equations and simplify the fractions. Now after substituting the partial derivatives in Charpit's auxiliary equations, we get these fractions dp divided by 2z minus 2px minus 2qy plus p into 2x plus d equal to dq divided by minus 2qx plus 2qx equal to dz divided by minus p into minus x square plus q minus q into minus 2xy plus p is equal to dx divided by minus x square plus q is equal to dy divided by minus 2xy plus p. Now you can see that the second fraction is dq by 0. Our second fraction is dq by 0. Now our next procedure is we have to dq by 0. This is also dq by 0 equal to say k, equal to a common value say k. So that implies we can write dq is equal to, all these fractions are same, so dq by 0 is equal to some common value, so we can write dq is equal to 0. So our next aim is we have to obtain a relation which involves at least p or q. So on integrating this one, we get q is equal to a. So we'll get q is equal to a. So let us take this as equation number say 2. Now using the given equation and this relation, we have to obtain the value of p also in terms of variables x, y, z and constant. So we have already obtained the value of q in terms of variables and constant. So if some variables are absent, then there is no problem. We have to obtain p in terms of variables and constants, x, y, z and constant, and q in terms of x, y, z and constant. Now we have to we can find the value of p also in terms of constant and variables x, y, z. So substituting this value in equation 1. So our equation 1 is this one. So substitute q is equal to a in equation 1. We get p is equal to, we obtain, try to simplify the result. So putting q is equal to a in 1, we get p is equal to 2x into ay minus z divided by a minus x square. So let us take this as equation number 3. Now dz is equal to p dx plus q dy. So that substituting the values of p and q in this equation, we get dz is equal to 2x into ay minus z divided by a minus x square into dx plus a dy. So next we will go for integration. But here when we look at the expression, we can see that here the direct integration is now not possible. You have to rearrange the term so that the numerator is an exact differential of the denominator. You can convert into that form. Since here we cannot, we can integrate integral dz, but we cannot integrate the first term 2x into ay minus z divided by a minus x square into dx, since it involves y and z. So here the integration is with respect to x. But when you look at the terms, you can see that a minus x square, if we take the derivative of a minus x square, that is 2x. Here we have 2x. And when we consider derivative of ay minus z, we can see that it is a dy minus dz. Extra differential is a dy minus dz. So here we have a dy and dz is there. For making some rearrangements, we can convert this expression into an integrable form. So after rearranging, we get dz minus a dy is equal to 2x into ay minus z divided by a minus x square into dx. Now this can also be rearranged as dz minus a dy divided by ay minus z. That can be written as z minus ay. 1 minus is taken as common, so minus of z minus ay is equal to 2x divided by dx divided by minus of a minus x square. So minus and x square minus a. So minus and minus get cancelled. So we get dz divided by a dy divided by z minus ay is equal to 2x divided by x square minus a into dx. If we put u is equal to z minus ay, then the total differential of u, that is du, is given by dou u by dou z into dz plus dou z by dou y into dy. Now substituting the derivatives, we get dou z minus a dy. And if we put v is equal to x square minus a, then we can write dv by dx. Derivative of v with respect to x is 2x. So it becomes dv is equal to 2x into dx. So that we can rewrite our relations of the form du by u is equal to dv by v. dv by v. So that on integration we get log u is equal to log v plus log b. So u is equal to, we can write u is equal to v b. Okay, now we can substitute the values of u and v in this relation. We get the answer. So answer is u, this implies z minus, or we can write log u is equal to log u is equal to log b plus log b, so that we get log a plus log b is log ab, so u is equal to vb. U is equal to v into b. Substituting the value, we get z minus ay is equal to x square minus a into b, or we can rearrange it as z is equal to ay plus x square minus a into b. So this is our required solution. Thank you.